Półtendente oktatok. your talk. Hello?
Hello.
Hello, hello. Okay, we're just going to wait another minute or two to start at 1:30. This is the cloud and DevOps track, right? I hope everybody had a good stretch and kind of refreshed after this morning session. I also hope you don't fall into a food coma and miss out on the exciting talks that we have this afternoon. Good, so let's introduce. We're going to introduce our speaker for the future of CI/CD, continuous code quality using AI. So Pratik Singh is a distribution engineer at GitLab, and he specializes in DevOps, Golang, and web development. So he'll take us through some new learnings on how AI, and specifically LLMs, can be implemented and introduced into the into the CI/CD pipeline. Okay, so Pratik, over to you.
Hello, hello. Okay. Hi, everyone. I'm Prateek Singh. Oh, did I get the clicker? Okay. Just one sec. Hi, I'm Prateek Singh. I'm a distribution engineer at GitLab. A little bit more about myself. So a lot of you might be confused what a distribution engineer is. So when GitLab as a software is built, me and my team is responsible for shipping it to the customers, whether it be via Helm charts, Terraform or Ansible scripts, or any other way like the .db packages and all. So that's basically my team. What do? I have been in DevOps for more than 3.5 years or so. I feel old. And I do a little bit of Golang whenever I get time. If you want to connect to me, you can scan my Twitter code and let's get started. So today, we'll be talking about the problem, why this code review by AI is actually needed in this industry. We'll be talking about the solution. We'll be talking about the workflow, how we'll be getting that. If I get the time, I'll show you the demo, and then we'll talk about the challenges around this. So, how many of you are software developers in this room? Software developers? Okay. How many of you actually like code reviews? Like getting it done by your seniors? Like enjoy getting code reviews? No one, right? So if you can see the meme on the left-right corner, that no one actually likes their code to be reviewed by seniors, right? It's bashing and it can get very brutal. So even as seniors, I can tell you that we also don't enjoy to bash anyone else's code. We also don't like to go through some common mistakes, small problems, small nomenclatures, or naming of the variables. So this problem I identified while I was working at my previous organizations, that every team that you work in software development, right, comes up with a set of rules within the team, right? It's an unsaid nomenclatures that comes around, whether it can be about the logging infrastructure, how the logging should look like, what should be a print statement, what should be an alert statement, what should be a warning, and it can be something about naming variables, whether it should be camel cast or anything like that, right? So a lot of companies come up with these set of rules within the team. And as a new member in the team, you will always be bashed in code reviews, right? Because you don't know these rules. You don't know that whether it's not only about writing code that compiles. We all can understand at this point, it's not always about the code that gets compiled as a good code. No. It's a good code if it is something that everyone in your team likes and it gets the work done. So this is the problem that I wanted to demonstrate. What is the solution regarding this? The solution that I'm going to present to you today is that anyone who writes code and makes a commit to the team, that particular changes, whatever changes that you have done in that team, that is reviewed by an AI or an LLM model under the said rules that the team comes up with. Right? So AI will go through the changes. It will say that, okay, rule number 1, this passed, rule number 2, that passed. I'll show you in the demo, it will be more clear then. How is the workflow, right? So as at the starting of the slide, I told that every team can come up with a set of rules. So the rules can be set up by your manager, it can be with your team lead, it can be a team exercise, right? And it's good that the entire team at the same page that how should the team's code look like, how should the microservice look like, how should be the logging infrastructure, how should be the naming conventions, are we doing a panic or not, are we doing a global variable, are we doing locks of the variables. Right? So these rules you can come up, set up those rules. Then you select an LLM model. At this point in 2025, I think all of us have played a little bit with LLM models. And you understand that not all of them are same. If you are using Quen, if you are using Llama, if you are using Mistral, you'll see the differences, right? And if you have used any code-specific LLM model, then you will understand the difference even more. A generic LLM model is not as good as a code-specific LLM model. So I have used Code Gemini, something from Google. That was really good at giving the next prompt, that what should be the next line in the Golang code. So as a team, you select that LLM model. Then what you need is a GPU CI/CD runners, because let's be honest, when it comes to LLM, GPUs are the way to run it. You can run it on CPUs, but it's your cost, your money. Then it comes to a basic Python. So the whole of this is knit together with a basic Python script. The Python script will do nothing. We all are software developers, we can understand that if a git commit comes up, so in the pipeline, the Python script will get that particular code, the changes which has come up. It picks up those changes. It invokes the LLM. it sends the rules that you made in the first point, the rules.md. It takes the changes and it just asks LLM that, hey, can you just make sure that these rules are followed or not, right? And once you have do it, so it's a can-do attitude, you have to fail multiple times and you have to iterate and just get to a final result. So if I'm talking about GitLab, it's this easy to get a runner on GitLab that is GPU based. You just have to add a tag and the image. So you just add this tag and you'll get a GPU runner on GitLab. In other platforms, I really can't say. But yeah, even if you want, you can host your own VM and connect to GitLab or any other code repository that you might have. Then, as I was saying, it is choosing an LLM. So in the demo, I'll show you. The pipeline is really not dependent on one LLM model. In particularly this demo, I have given the users an option to select any LLM model which is available on Ollama. So as you can see, it's a variable name that you define at the start of the pipeline. You can just define that I want to use Llama 3, I want to use Mistral, I want to use DeepSeek, up to you, right? Once it takes that LLM name, by default I have kept it as Gamma for the demo purposes, but you can keep it anything. It just checks that you have provided an LLM or not. Then, preparing the runner, this is the most basic step if you are sitting today here in a CI/CD track. I think and I hope you all understand what's preparing a CI/CD runner means. Means it basically, in a very layman language I can put down is, CI/CD runners are mutable computers that come up, does a set of rules, and then it dies. So because it's a new computer, you have to set it up. Like every time you buy a new laptop, right? You have to set up the OS, you have to set up some things. This is similar what we are doing. We are just setting up packages since we are going to use Python. So that's what we use. We install packages of Python and then we move on to this step is actually the most important in the entire demo. So why this is important is, so Ollama is a software that helps you run a lot of LLM models from within a container. So to install Ollama or installing and running a LLM model from the container is just these 3 commands. So basically you just install the binary, you download the binary, install the binary, and you run this command. Once this command is run, now the CI/CD runner has an endpoint on which an LLM can accept any prompt. It's not necessarily about your code, it can be any prompt. So now it's about the Python script as I was mentioning. We all have worked with Python scripting a little bit, I am assuming. So it's basically just an endpoint that is available on your local or in the runner itself. There is an endpoint on which a LLM model is already running. So you take the git changes into it, you take the content of the rules.md, and you take both of these and send to the LLM endpoint, right? Now, I think I can show you, if you guys are interested, you can scan this real quick. Yeah. So this will actually redirect you to a repo on which this is an actual job in which you will see how this entire demo works, right? Once you guys are done scanning it, I will proceed. Yeah. Yeah, good. Shall I proceed? Okay. So how does, if you are able to look on your phones, it's well and fine. If you scroll to the real bottom, if you go at the very last steps of this job, how does it look like? It just says that, hey, these are the changes or these are the rules that I will be checking against, right? On the very first step, you'll see here that AI will be checking your code changes against these rules. So does it have print statements? If you have worked in a production environment, we all know we don't prefer to have a lot of print statements in that. Are the variable name camel case? This can be for the fanatic teammates or the seniors who are very fanatic that the code should look like that and this. Then does it have error handling setup or not? So when a fresher or someone new joins in the team, they might have forgotten while writing the code. It's not like the code is not compiling. It's not like it's not getting the implementation done. But error handling is really important in any team because anything can go wrong in software, but we should know where it went wrong. Then does it have a logging setup? Does it ensure modularity of the code? So now after it has seen all these rules you see over here, it sees that, okay, what are the files that were changed in this particular commit, right? So it will say that in this job, we will be checking these files. So since if you have on your phone, you can see the repository is a Golang repository. So it's only focusing its changes to main.go file, right? So as I said, every rule at a time. So it sends to the LLM model, does it have print statements, right? So this is the answer that the LLM model is generating. That false, the given code does not have any print statements. So that's why I was saying that selecting the right LLM model is important. If I would have used DeepSeek at this point, it would have given a very long answer to me that, I think that this is there, that is there, not there. That's why I said that a small LLM model is important in this demonstration. Then the next question is like, are the variables camel case and all of this, right? It does not have error handling or not. So it can tell that no, it does not have an error handling. So now with this entire demo, I think I'm safe to say that you might have understood that it will reduce a lot of code reviews by your seniors, right? As a senior, you'll not be troubled a lot for silly mistakes that maybe someone who new joins in your team will do, right? Because they can just go and see that, okay, the job failed. And as you can see, the logs are pretty beautiful. I have written it very well. So it's very declarative, and it's just saying that, hey, this is the reason that I'm failing the job. Your job does not have error log statements. That's why I'm failing this job. That's why this pipeline will not be proceeded, right? One extra scope. Do I still have time? I still have time, right? Yeah. So one extra just scope I want to introduce while I have time. So understand that this does not have to be limited to your CI/CD pipelines or your CI/CD runners. You can do this locally as well. It's none of the steps that I showed, none of the jobs that you see in this are specific to a CI/CD runner. You can done it on your local. Reason why I did it as a CI/CD talk is because this is a review. This is something that your entire team has to go through. So it's better if it's at one common place, right? So I think that's all that I have. Any questions that you might have? Yeah.
Is it deterministic? Like if I run the same runner 2 times, is it going to always give me the same result?
So when you are doing anything related to LLMs, right, you have to be very specific about the prompt that you generate. The reason that you can see true and false in the demo that or the screenshot that I saw was because if you check that repository, in the prompt itself, it's very clearly written that answer first in true or false, right? So that is one step that I am just guardrailing the LLM, that you have to first tell me a true or false, and actually the job fails if it's not a true or false. So the LLM is strictly advised that you have to answer first in a true and false basis, and then you can be as subjective about it as you want, right? I think that answers your question.
So in your experience, does it always give you the same true?
True and false is one thing that, yeah, true and false is one thing that I have always seen. The answer behind true and false, that why it is giving true or false, yes, that sometimes can change because, yeah, it's not deterministic when it comes to LLMs. And to be very honest, this is not something that I want to keep it on a, on a very production heavy pipeline where everything is getting merged. No, this is for something that you want, your developers are coming in and there are a lot of code reviews coming your way. So this can, save you a lot of time.
Thank you.
Yeah. Any other questions? Yeah.
Yep, I'll bring the microphone.
Yeah, I just want to add what he said. I mean, large language models hallucinate.
Yeah.
And they can miss important part of the code reviews. Now, what you are saying is that, it should be like one part would be LLM reviewed, and then it would be manual reviewed as well.
Yeah.
But how does it save time to enterprises? Or do you think that it will save time and, in maybe 1 year or 2 years down the line, we will actually see that LLM is pretty smart at doing the code reviews, given the right context, and now you don't need manual reviews at all?
True. See, I'm in no way saying this, human in the cycle is not important. A human in the cycle is always important. When it comes to hallucination, if you saw the entire talk, every time the runner is pulling a new LLM model, hallucination usually comes when you keep using the same model over and over again, right? Because it gets confused with the context, the previous questions that you asked. If you have used ChatGPT, you might have experienced this, that because of your last previous questions, it might have got confused. So every time it's a new model, right? If you want, you can get your own own model that your company hosts and it can be trained that way, right? Then you can even stop hallucination more. When it comes to saving time, I do believe it will save a lot of time if you have new folks coming in on a regular basis, or you have people who are new to the code base at least, right? Yeah, when it comes to people who are pro at it, they might not need it. It can be a job specific to some branches. I'm not saying that it has to be, as I said to him, it's not has to be on the production pipeline. Yeah.
Just one last question. In your experience, which is the best or top 3 models that are really, really good for code reviews, and especially which are the models that are not really good at code reviews and I shouldn't be using them at all?
Okay. See, to be very honest, I don't work with LLM models, so I'm not speaking at a professional capacity. I do work with LLM models on my own spare time, so my opinion would be based on that. When it comes to specific to code specific things, then I would suggest not to go for something with bigger context like 7 billion model or 14 million model. It can be anything. It can be DeepSeek. It can be Mistral. When you go for a very big context, it usually starts not only to tell you the problem, it starts explaining you the code, right? Because the bigger models are built that way, that it is there to explain you. So I would suggest to stick to smaller models. What I have used is Gemma. So Gemma is from Gemini. So it's very specific to coding. Then you might have used Claude Sonnet 3.5 I have used. Actually, I use that a lot. So that's really good when it comes to code specific things. And then I have used this, I'm forgetting the name of it. It's from Mistral, I think. I'm forgetting the exact name of that model. But again, it's very specific to the code repositories. So if you want to write it a Python code or something, so it will just tell you the Python code. It will not say that, hey, this is the reason or this is why Python existed, right? So yeah, I think that answers your question, right?
Yeah, another question in the front here.
So checking for camel case, for example, in variables, is a task that, well, take it or give it can be done also with a grep command.
Yeah.
But when it comes to something more, well, in-depth questions like, okay, you have a lot of blocking code and you should do this, put this maybe in a coroutine or something like that, then it becomes a little bit more challenging.
Yeah.
So what is your advice how to transfer the knowledge of the senior developers into those MD files that you just proposed and write the right prompts for that?
Okay. So very first thing I would like to add that yes, please don't confuse this entire talk to be a linting kind of job. No, I don't want that. I don't advise anyone to reinvent the wheel that already exists. So if there is a linting job that is capable of doing it, please be happy and use that because it will save you a lot of time and cost. When it comes to what you have said about the using of Go coroutines, like because I'm from Golang, so I'm saying Go coroutine, sorry. But if you have to do something like that, when you define the rules, right, then you have to, in the rules, you have to be very specific about it. Yeah. So you have to be very specific about it that if there is an opportunity that multiple things can happen. So in the rules, you define it that way. Prompts are very much easy to set and it's a one-time job. What is more important for you is to set up those rules. That's why the very first thing in the workflow I told that you have to set up the rules very, patiently. So it's about your team managers and your senior developers that have to sit through and have to set those rules. I think that answers your question. Yeah. Thank you. Any more question?
Yeah, we got a full house. Any more questions? Interesting topic. Don't be shy. Okay. Just a question, Pratik.
Yeah.
Seeing as you work for GitLab, right?
Yeah.
Obviously this is something that adds value to the overall kind of STLC process, right, through to shipping code.
Yeah.
Is this kind of pre-processing of code analysis something that you think the source code platforms would build in as a native feature that you can turn on and off? Because you are doing a kind of commit, you're doing a PR, perhaps
Yeah.
something to scan the code.
Yeah. So if I'm not speaking on the terms of GitLab as of now, I'm speaking as a developer, clear as a developer. So if you think a few years back, I was working at some startups, and for every job there was different thing. So there was source graph, and there was for scanning of vulnerabilities, then checking for keys. There were different services, right? But if you see in 2025, you have got GitLab secrets, you have got your own model registries on GitLab, you have got your own container registries on GitLab. So it is a difference where a product can just consume a feature and add it into itself, and some things can just stand by on the editor. If I'm talking this talk over here, someone can pick it up and can make a product out of it, or maybe someday at GitLab I make it and add it into GitLab, I don't know, right?
Good answer. Good answer. Oh, we have some more questions. It's great. We have a bit of time.
Hi, okay, I'm from Palo IT, named Yui. So my question is, for example, if I have like three rules that I want to attach to this like LM model, is this count as 3 tokens as well?
No, actually tokens are not counted that way. Tokens, if I'll not get deep into LLM tokens because I have not done that as I was speaking on a professional level, but that's not the exact way you count token. It's because when you give a prompt, right, your rule will go, your code changes will go, and then that adds to the token, right? So it's not like one prompt is 1 token. That's not the exact idea.
That would be cheaper.
Yeah.
Thank you.
Yeah. More question.
Hello there, thanks for your presentation. It's very useful. Actually, we've been applying this technique for quite some time. We did research and we apply, first thing is one local by Jira, Atlassian, ChatGPT.
Yeah,
the
yeah,
second
yeah.
one we use Codium.
Okay.
And we found 2 issues with that. First, I really like the sentence. You put at first, no one like senior review.
Yeah, correct.
I'm currently a technical leader, and when I review, they avoid it.
Yeah.
So, but when the AI review, it's not fulfilled to me.
Yeah.
No matter the rules,
Yeah.
somehow there's still some more context that need to be fed. And we're working on building our own model so that we can feed our data train into it.
Yeah.
And it's kind of ton of work, still working on it, but I'm not sure this is the right way. So do you have any advice?
So the idea that I pitched today here, I'm using a generic LLM model, right? I'm pulling it off the store and using it off. It's really up to you, and the data is entirely on your own CI/CD runners. The runners just die after that, right? So whatever the data of your own company is, that just goes off. So it's not being sent anywhere, right? If you really want to train the LLM model on the rules that you have set up, right, then you'll have to make a feedback loop where the LLM gets the answers. You say that, yes, this was a good answer, and then it gets trained, right? So yeah, I think that was just 1 minute we have left. I think I answered your question?
Yeah.
Yeah, I hope so. Yeah.
All right. Shall we close it out there? Just a round of applause for Pratik.
Thank you, thank you, everyone.
Thank you. Good, we got a short break. Where's the next speaker?
I hope I did not trouble you a lot.
Yeah, that's you were You have 5 minutes. I will show you the time that you have left. The first one is 10 minutes. So if you don't see it, it means half time. The first one is 10 minutes, and then 5 minutes, 3 minutes, and 1 minute, and then time out. So would you prefer me to stand back here to see me easier? Show you the time. Okay. And you should stay. Alright, it's easier to see, but it's fine for you to walk around.
We have the clicker, yes? You want to test if it works?
Okay. This one I'm going to need.
And subtitle. Thank you, sir.
Subtitle.
Sure. May I put my phone there first so that I can see my timer? Yeah.
Yes, exactly. We try to keep to the timings, right?
Yeah. It's a very tight schedule, so
Okay. Yes, the first one started finished early.
yeah, that never happens. But yeah, the schedule is very tight, and there's just 5-minute breaks, which is wrong.
It's quite tight. How many screens are connecting to these streams?
I have no idea.
No idea.
No, that should be visible somewhere. I'm not sure where. There are 2 places we stream, and one of them is a Chinese platform, which I have completely no idea about.
Okay.
Should not be presenting, right?
No, as soon as I plugged it in, it was streamed. So if you start typing your passwords here that are visible, that's not a good idea.
In Thai world, we see.
In Thai. And you can type your passwords in Thai.
Oh, that's
Using for your slides, like how do you get the video?
That one? Oh, Apple.
It's Apple
Keynote.
Keynote. Yeah. Thanks, Steve Jobs.
Thank you, Steve Jobs.
You know.
I'm going to ban Max from conferences. This is a horrible laptop.
Yeah, I'm agree, but still using it. I used Linux though before.
What were you using then?
Yep.
I almost
Google Slides.
yeah, Google Slides mostly. I just buy the new laptop and I almost formatted and installed Linux, but it have terminal for me.
Oh,
Yeah,
exactly.
Yeah,
You don't
I-
need anything else.
yeah, I don't need anything else.
We all want
So that is good.
Let me just make sure to name like that. Cheat.
And I stop.
Sounds very Japanese.
Yeah, it's like my
Oh,
call sign. Yeah, I am a Lamsing programmer in Thailand. Lamsing is, pop and rock. It's a kind of music.
Yeah.
In Thailand, Lamsing is the northeast style of music in Thailand. It's a local one.
Local one, so you're like a local programmer.
Yeah.
Lamsing.
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 It's okay.
Okay.
I don't mind.
It's okay. We can get started actually. So.
Okay, up to you. Yeah, I'm ready. Go. Sure. Sure. Yeah. Thank you.
Okay. Okay, good afternoon. This is the second session of the DevOps track, and we're going to have another 25-minute presentation by Anu Chitto. He's a self-declared Lamsing programmer from Thailand. Some of you might know what that means. And so Anuchit has led high-performance teams at ThoughtWorks and Arise, and he's kind of passionate about delivering solutions that enhance business agility, reduce cost, and drive business growth. And so Anuchit, you're going to present to us today on how Golang can help teams overcome the challenges of promoting good software engineering practices. So,
Right.
over to you.
Thank you. That is very good introduction. Yeah. Thank you everyone for come. Anyone here a programmer? Okay. Anyone here writing code right now? Still people writing code. Okay. A Java? Okay. JavaScript? Okay. Any PM or BA or QA? Infra? DevOps. Okay. Very good, sir. All right. As you can see, English is obviously not my first language. So if I say something is nonsense, helping me correct it in your head, please. Okay, that's what I ask for help. And I might mention other programming, but I know have bad intention because I wrote a lot of programming in my company as well. And I probably show nothing new here, but I want to shift the way of thinking and the way of seeing through Go, that what I'm seeing, so that you can apply that one to any language that you are working on right now, okay? There is no pipeline configuration here. What about that? Because I don't think that we have the configuration, we have autonomous pipeline, and it will get you faster. No, we need to change something or shift mindset or viewing the new problem first. So, last but not least, please helping me look beyond Go language, because what I'm trying to share here is underneath the hood of that language, right? Okay. At first, some of you might see this one already, but I will open the video and then if you can you pick up the challenge or the issue or the problem in this song? That's what it's talking about, right? Okay, it's about Go. It's about Go. Oh no. Okay, one more time.
Schedule's tight on the cluster tonight, so I parallelized my all those threads and continuation.
Very good. So I hope any tech lead here, be careful. But the first advice that should not be write whatever you're writing right now with Go. Okay? So, as you see, most entire the song is mostly not talk about your algorithm is not fast enough. Your code is not look beauty. Right? It more challenge that we are facing in software development. It's not just coding. For example, if you do a web application, that's more simple. After you done coding with the React, for example, is that done? No. You need to hold it somewhere, right? Where is the domain name? Where is the public IP? Where is the server? Right? Is that, can you just ship it right away? No. How can you qualify the quality? How can you test it? Right? So we need those things in place. How we make sure that our application is working fine with other application. How it connect to each other. Right? So it's a lot of things that we are facing right now that more than a code. But sometimes the language is also the important thing. But it's not the most important thing to get the job done. People a lot of saying that the language is just a tool, right? So here, I want to shift us a little bit. It's not just about the language. It's about the software engineering that we are applying to our workflow, to our software development process. But people still asking, which language that I need to use? And often people say, hey, what you are going to do? The language is just a tool. Have you heard about that? Sometimes it's so annoying that the language is just a tool. But how can I do know that which tool I should use for which job? That is my question. If you say, choose the right tool for the right job. Is that right? If you are a senior engineer who is considered themselves a senior engineer here, excellent. If you've been here for long enough, you will know, have no doubt, that which tool that we need to choose, which language that we need to choose, right? Obviously, this section of which language is Go, right? So that means everything that you want to write, you just do it in JavaScript. JavaScript can do everything. So that's what is the purpose. The one thing that I most face challenging in the JavaScript is the dependency. I don't know if I am alone when I go to the office and turn on my laptop and start my program. Sometimes it just crashes. It's just not working. The magic thing I do is rm-rf node module. Hit enter. And I restore dependency without doing anything. And it just works. How do you know that? I thought it's only me. That is a terrible thing. Every time that I need to fix this small issue, it spends like half an hour to download new dependency, to fix all of this annoying stuff. And if you have experience on the bigger project, that is super challenge for you to keep the backward compatibility, for you to keep your application deployed and it's not cached, right? You need to avoid to put the, this one in your version, right? You know it. So Google have this issue as well. They need to handle this thing, and in the language that they're using is a lot, right? So C++, Python, also one of them. Yeah, JVM, blah, blah, blah. It's in here. One day, Rob Pipe, the inventor of Go, who is the creator of it, changed line of code. It just few line of code. And he hit enter, and he waiting for it build. It took 45 minutes to build. And he thinking, this is not right. Why? Because when you render the 4K video in 1 second, how many data that is rendered? compare with your code base, just compiling. Why is the rendering is faster than just compiling the code? And he take a look at the header file, and it have one header file that's recompiling like 37,000 times, because the compiler can't know that it's already compiled. It's recompiling that file, and that's its waiting time, right? And Rob Price say, okay, I don't think this is the solution anymore. We need to develop a new way of developing software. He not intend to create a programming language, but he want to create a new experience for developing software. He come to Robert Kirsimer. This the one that writing the contributing in the JVM hotspot. Yeah, this guy is implementing it, and he convinced the Ken Thompson. This is a god. Come and helping me design the first version of Go. And at first, Ken say, "Oh no, I don't want to join because C++ 11 is coming out." And he go to C++ 11 spec, and he see, okay, I will create a new language, because he convinced that that's not gonna solve the problem that we are facing right now. We try to probe the entire chain of the problem. Okay, how that gonna be done? Rob Pipe drive home, and then he suddenly come up with his head, oh, I know what language should be named. And then he got home and he write this email and say, hey, this language should be named Go, because it express the simplicity, blah, 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 blah. The tool is just Go C, Go, blah, 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 blah. And then they have the guideline principle to design it. So some of us, if we see Go, we will see there is nothing new in Go language. It's just the thing that it already exists, right? Tony Hall said this one, yeah. Your task of create a new language is not inventing the new things, but you just compose the thing that is already exist to make sure it's smooth and working together. Tony Hall is the one that originate the CSP model, yeah, one of the concurrency model. And the keyword of Go is just here, 25 keyword. That is for a long time, almost 10 years already. So, and they said, Go need to be different. It cannot be growing and like other language. If you imagine right now the language is growing up and they add more feature, and the language becomes similar. But Go not that. Go don't want to be like that. Go want to keep it simple, but it have price to pay. So that is they end up starting building the language. So Rob Pai said the code is hard to understand. It's simply because it's using more complex language to writing it. If we have a simple language, it's code more easier to read. That also true in one aspect, but not for all, right? This is the thing that I want everyone to realize, that how Go successful to doing this. And we should doing this in our software as well, because we cannot just keep breaking other system. When we build a software, it have a system around us, right? So we need to make sure that our system with new release is compatible with other system that we are doing. And that's what Go showing us. This is for 10 years, Go showing this one. That is still working that way. And the one thing that's Go showing us is the version manager in Go. There is no such thing, because the Linux just work on the command line, right? If you have Go version 1.9, you can have that one, and you can run it simultaneously in your shell. But other language is not manipulate that way. If you switch the language, you cannot run two versions simultaneously. Cannot. It's just hard. Go, it's just you add one variable, environment variable, and you define, you run it. That's it. If you don't have it, it download it for you. Just simple as that. That's the way to think when we develop software. And in Go, we can use one version to two versions of source code. This one, when we work in the legacy system, the file that is depend on the old version of library, and sometimes we cannot update it. Because if you bump up the version, it will crash on you, right? But new feature that we want to add, it requires a newer version of that library. How did we do? It's so hard in other language. In Go, no, you just import it and using it. That's it. That's how simple it is to think about that one. I don't say the implementation of it is easy, but the way it's expressing is simple and it's compatible. And at first, Go don't have the Go module, the version manager tracking. No, don't have it. And when Go have it, Go explore all the existing community tool that we are using, and then Go combine it together, and Go provide the way to migrate entire world to use Go module without breaking anyone by using this one, the environment variable. To ship, at first, Go announce, hey, we will introduce this new variable, and it will off by default. And if you want to migrate to Go module, you can turn it on by yourself. And then they have the stage to make it auto. That means auto means if you outside the Go part, it will enable the Go module by default. If you inside the Go part is just the old way of writing Go, it will turn off the Go module by default. So that means your project, if it's working, it's still working. If you create a new project, it's Go new way. And they transition this one, and then you can transition with them with the new version release, and then you move to the new world. This is what is called feature flag in real life, right? It's just another form of it. That's how we maintain the backward compatibility. Our software need to do something similar like this to not break other version of it. Testing is the most crucial thing. In Go, it's just there. If you think testing is not hard, I bet you, if you have the project, maybe .NET or JavaScript, that is legacy project, and you try to add the testing library on it, it's not going to end well. It takes a lot of effort. But Go is just there. If you have legacy project and there is no test, you just add one file and run test. It's just already there. This is a crucial thing to have. And when we develop software, we need to think about this crucial thing, that which one that we need a tool inside our software development process. Which one we want to keep us going forward more easier, right? Test private function. How can we test private function? In Java, make it public. In Go, no, it's just a function. You can test it. It's just normal function. It's just not exported. Yeah, you just test it. That's it. How do you do formatting in other language? It's so hard. When I come to other language, I need to install many things. In Go, it's just this one, this line. If you don't have the plugin IDE, just run it. That's it. Entire world, if you writing Go, you have same formatting. That's how the way of thinking is. This one, the tailing comma, how many times that we fall down with this just small thing? Go say no. You need to add the tailing comma every single line. That solves the problem. Switch case, how many times we put break on it? Every time. Go say no. This is just default. You don't need to put a break on the switch case. It just break for you. If you want it flow through, you just add flow through it, and it will flow through for you. That's a shift the way of doing things. Is this new? No, not new, right? The source code file is just a file. It's just a file. You can open it in any IDE that you want. It's UTF-8 file. Just that's it. It's compatible with any IDE that you want. The package in Go is just the structure of the way we structure the folder in Linux, right? It's just a path and the folder and the file. That's it. So it's well structured enough. Personally, when I clone the new project, I follow this structure because it's separate by domain by default. When you go get or download dependency, it just organize your code very beautifully. And when you want to find it, it's there. It's just there. That's the way to think about it. go.com.github, no. The github.com is a domain. We separate a file from domain, right? Inside that one is subdomain or subservices. Up to you. It's just that. It just use the existing tool to achieve it. It use existing way to achieve it. When you import, it just import it. You will know where it's a part. Other language is not. The thing that you see in the file and the thing that you see in the IDE is different thing. This is just the way to think about it. When you want to publish your package in other language, which registry that you want to register, you need to create some file and put it there and push to that registry, right? Go say, what you have the version Git version control for? GitHub, GitLab. What you use it for? You didn't store a file for versioning your software. Go it just init and create your project and push to Git, and it publishes already. It's done. It's done. You don't need to do anything more than that. That's it. Use existing to work well with your workflow. And the error in Go is annoying thing, but they said that if you have a lot of error, that it indicating you that we do something wrong. Because most of the time we don't need that much error. Go is very strange language for me. For what? Because when I wrote it, if it's something wrong, it feels hard. It feels strange. If it's right, it feels normal. It just, this is what it is. And you can go to another task and do another thing. Zero value is there. When you new object, it's there. You can just use it. There's no new pointer if you not use the pointer. If you use the pointer, up to you. Okay, the concurrency is native. In Go it's just there. If you want it, it's there. It's not a library. I stress that one. Go concurrency is not lib. It's a language. It comes with language itself. So that is consistency. The cross-platform compile. This one is so interesting because we need to deploy on the ARM, we need to deploy on Linux sometime, right? So many architecture. With Go, you can just do this. Put two environment variable and specify your architecture, and you will get it. That's it. How simple as that? Okay, if you don't believe me, try to compile the cross architecture with other language. It's quite harder than this. So this is all the languages, the architecture that it provides us. And when the time that you want to optimize your code, it's already there. The tool is there. You just don't need it in the first page, right? We need to deliver feature, and when you see, oh, it's time to optimize, it's there. That's the tool. It's ready for you to use. How convenient it is. Okay, it few dynamics, and this is orthogonal design that we can design is like we want. So, okay, what I mean saying is the programming is just when you are writing the code. The software engineering, that's what we talk about, right? When you're writing the code, when the time over and you add more developer on it. That's the problem of software engineering. Git is the one tool that for software engineering to show you that how it's done. Git not help you on the programming thing, right? It not help you on your algorithm is faster. No, it's helping you on the corroborating the problem. Okay, so this is the last thing that I want to leave you. Don't learn the programming language from Go. It's nothing there. Learn software engineering from it. Thank you.
We're just good for time, so any questions from the audience? I think I only saw about 10% of the audience raise their hands earlier on using Go, so the rest of you clearly have a homework assignment by Anuchit to start learning Go. Any questions to the expert? Okay. Well, we'll take it offline then. So Anuchit, thank you so much. Appreciate your conversation.
It's a good job.
Which ones were yours? Enabling. This one. Okay.
Okay, good. I think you've done this many times.
I think this is my second time.
Oh, FOSSASIA, okay. Cool. How do I say it? Ahmad? Safnaj.
Or just say something.
Do people call you Safnaj?
Yeah.
Yeah.
That's my last name.
Yeah.
Shall I go and
Just 1 minute.
we have a couple of minutes, right?
2 minutes, 3 minutes. I will show you the time. Okay, we get started. Presentation is 25 minutes exactly, or shorter? Okay, then we're good.
Sometimes I have to make it fast.
There you go, make it fast. Okay, so maybe we just get settled in. All right, so we're still continuing on this afternoon track featuring on cloud and DevOps. Now at 2:30, starting a session for 25 minutes on enabling continuous delivery with feature flag strategies. So this is for the hardcore engineers in the room. So I welcome Amit Safnaj, a senior software engineer out of Sri Lanka. And he's been very involved in the open source community and also working together with students and supporting the engineering kind of discipline at large. So just a round of applause for Safnaj. Thank you.
Thank you. Good afternoon, Thailand. I hope everyone having a great day in this DevOps track. I guess it's not so boring. Before that, shall I get some insight from the audience? How many of you are students? I brought some gifts. Okay, couple of people. Nice. Okay, anyhow, I planned this session beginner friendly. Let me start the talk. Let me introduce myself first. My name is Safnaj. As he said, I'm coming all the way from Sri Lanka. I'm working as a senior software engineer at a company called Cisco Labs, and I'm a community person. These are some local tech communities that I represent in my country. And if you got any queries or if you want to get connected with me, you have my social links there. You can reach me out anytime. That's pretty much about me. And my agenda is simple. So I'll be starting off with what is feature flagging and what are the benefits of using it, and the problems that we are having in the traditional deployments, and also a bit about A/B testing. And I also have built a small demo applications. And at the end, we will have a QA as well. Okay, let me start with the questions. Actually, it's a gift question. What is a feature? I don't need fancy definitions. Somewhat your understanding is fine. Can someone just raise your hands and tell what you understand by feature? Students? No? I don't want to take the gifts back to my country, so any wrong answer is also fine. Yeah, go ahead.
Anything that a user interacts with in your software and that they want to talk about or ask about?
Yeah, anything is fine. So in my understanding, there is no fancy definition for a feature. So if you ask me, feature is an important part which can ease human efforts in a productive way, maybe with a better user experience. So that's what feature is. But sometimes bugs becomes features. So we developers used to say this, right, a lot of times. It's not a bug, it's a feature. So meet Isuru, you can see him around FOSSASIA tables. So we can say these excuses for our academic projects or a small scale of projects. But imagine if you are working for an enterprise, you can't say this stuff, right? So we will discuss how we can escape from this typical thing that we used to say. And what is feature flagging? So feature flagging is a software development technique that allows you to enable or disable the feature without doing any code modifications or requiring a redeployment. So if you still struggle to understand, how many of you are React developers? React or any front-end developers? Okay. In React, we have this term called conditional rendering, right? If this is true, render this component. If loading is true, render the loader, likewise. So we put a feature behind a flag. So you can always control the feature with your Boolean values or anything. So if you still struggle to understand, it's not a rocket science, but just a key value pair stored in the cloud. Just a key value pair which will be stored in the cloud. So let me talk about how feature flags works. So imagine, let me give a couple of examples. So I work for an organization called Cisco, which is in US. So we have more than 700,000 of users, and we have getting orders more than 200,000 every single day, and we do business in 90 plus countries. So sometimes we have to enable certain features for certain regions only, and sometimes since we have multiple customers, we have to restrict some features based on their roles. So we can still achieve that with some source code modifications, but what you have to do if you want to make some changes, you have to do the code changes and you have to make the deployment again, right? And let me give one more example that you might familiar with. Everybody use WhatsApp, Instagram, right? So sometime, let's say Instagram released a feature. You and your friend got the same mobile phone, same OS version, same application version, but your friend got the update, but you haven't. Have you faced such situation? Yeah, same for me as well. So what we used to do, we usually uninstall the application first, then we reinstall it, then maybe we restart our mobile phones a couple of times, and also even we can try some different VPN profiles. So what happened is the feature is not enabled you for yet. So that's how company ships features. When they releasing new features, they don't just push to 100% of their audience, they gradually roll out the feature. So why we need feature flagging? Again, a meme with myself. So anyone had an experience with production bugs? Anyone? Wow, so many. It's a nightmare story, right? I had one when I joined a company. So it was a kind of a UI glitch. Somehow I didn't notice, and even unfortunately our QA people also didn't notice that, and it went to production somehow. And then the end users reported the bug, and I had to work on the hotfix, and we released the fix in our next minor release. But since it was a UI glitch, it wasn't impacting our business. As I said earlier, we get more than 200,000 plus orders every single day. So imagine if my bug causes the impact of our business. If the users are unable to place orders, what will happen? That's how companies getting lost, right? So we should always park new features behind the flag, then you always have the control if something goes wrong. And let me talk about the problems that we are having in the traditional deployments. The first one, big bang releases. If you are launching multiple new features at once, there is a high chance of getting a big bang no matter how many times you test. And then rollbacks are really painful. If you are not using feature flags, the only option you have is to roll back your deployment. It's really painful, especially when it comes to microservices architecture. And lack of gradual rollouts. As I said earlier, if you are not using flags, you have to deploy the feature at once for your whole audience, which can lead to some breakouts. And dev and ops team coordination issues. Sometimes your dev team working on a feature which is already in progress, but your operation team took the code to a production, which can break some existing feature or break your entire application as well. And there is no room for A/B testing. Feature flags and A/B testings are tightly coupled. If you are not following flagging practices, you are not able to do some A/B testing. I will talk a bit about A/B testing in upcoming slide. And let me talk about how feature flags enables as continuous delivery. So the first one, decoupling deployment from release. So deploying your code to production doesn't mean that you are releasing the feature, right? So you should always have to have a release control for your features. It's not just the code deployment. And enabling canary release. So again, a gift questions. What does it mean by canary release? Yeah, go ahead. Sorry? Exactly. Okay, I will give the gift after the end of my session. So gradual release is the correct answer. So I discussed this term before my talk in previous slides. So when companies releasing, they will start with maybe a 10% of their audience. Then they're checking the logs and error monitors and no bugs reported. Then they will increase to 20% of their audience. Then again, we continue monitoring. Likewise, we increase to 30, 40, till 100. And it helps us to reduce risk of failures. So as I said, things can go wrong, right? No matter how many times you test. If something goes wrong, you have the control, you have the switch, you can always turn off the flag and work on the fix. And experiments, sometimes you have to experiment from your end users what they want. So feature flags allows you to do some experiments from your end customers. And easy rollbacks, if something goes wrong, you can turn off the flag. And test in production, which is highly not recommended, but sometimes you have to work with the real data, right? Maybe in that kind of situation, you can enable particular feature for your QA team only, and then they can test in production with the real data. And if you are using feature flagging platforms, there are like ready-to-use conditions which you can leverage. The first one is app, country. Let's say if I want to enable certain features only for Thai peoples, I can do that. So I don't need to write so much code for that. It's a remote config, so I can easily do that. And if you are targeting any app versions or a random percentage or people who are speaking kind of different languages, you can customize these parameters in cloud. And some feature flagging platforms allows you to have Google Analytics property. So apart from the one that I mentioned here, if you have any of your own custom properties, you can leverage Google Analytics properties in your feature flagging platforms. And let me talk a bit about A/B testing. I hope anyone aware about A/B testing? Okay, one. Okay. That's nice. And A/B testing, it's something that if you have different opinions, let's say a client needs something else, but your product owner suggesting something else, at the end your manager wants something else, right? So if you have such different opinions, why don't you test that from your end customers? So A/B testing is something that you can give all the opinions to your customers and see what the customers want. So let's say we have two kind of applications. One, let me go back to the slide. In this example, you can see that there is a donate button in the bottom, and the another one have a different variant which is in the top. So A/B testing is nothing but comparing two different versions of your applications and determine which ones perform better. And you can even automatically determine the winner. Let's say you are running this experiment for 7 days or a 30 days period of time. So at the end of your experiment, it can
make the winner as a default behavior. Then you can work on the code cleanup later. And you can make data-driven decisions. So it's allow you to say from I think, I guess to I know that. I know this is my customers want. And you can understand user opinions from the experiments, right? Instead of sending a feedback form to your customers and asking them to fill it out, because no one do that. So what you can instead, you can have an experiment and see what your users are preferring. And to run an A/B testing or an experiment, you have to set a goal, what you are going to achieve. So whether you are going to have more clicks for the button, or on a watch time, maybe if you are a streaming platform, and maybe you have to have a proper goal set first, and then you have to define all the variants. In my case, I have 2 variants. Maybe you can go for any number of variants up to your wish. And then we have to have a target, whether you are going to target your 100% of the audience. In my case, I am targeting 20% of iOS users. So here we have the 2 variants, and then I will be running this for a limited number of days of time. Okay, here are some best practices that you need to follow when using feature flags. The first one, categorize the flags always, because we use feature flags for different purposes. It could be a release flags, it can be a experiment flag, it can be a permission flag. So make sure you have to have a proper categorization, or else you can follow some good naming practices. And the second one is keep the flag short-lived. So feature flag is not an option to keep it forever. So you put your feature behind a flag. Once it's fully rolled out to your customers, what you have to do is you have to, like after you're done with all the testings and reports and stuff, you have to clean up the code. You have to remove the flag and make the default code as the final one. You have to perform some code cleanup as well. The third point, separate deployment from release. Always release new features behind a flag. So which allows you to decouple the deployment and release. So if something goes wrong, you can always turn off and work on the fix. And use flag management system. You can still achieve flag management behavior without using any platforms. You can define the stuffs in the constant file, or else you can define the flags maybe in environment variables, which is highly not recommended. Always use feature flagging platforms, which allows you to give a lot of ready-to-use conditions and a lot of debugging options. And secure the flags. So some developers, I saw that they use sensitive informations in feature flags. They have this SDK key, API key, and secret stuff. So avoid having sensitive information in feature flags. And yeah, those are the best practices that you can follow. And here are some of the feature flagging platforms or feature flag management system that's available in the market. The first one, LaunchDarkly and Flagsmith are very well-known products in the market. And Firebase Remote Config, that is the one I personally use and also use for my demo. So if you are looking for a free solution, every Firebase project can have up to 2000 parameters. I think 2000 is huge, which is more than enough. So you can leverage Firebase remote config for your feature flags. And if you are coming from an enterprise company like Cisco, we use Optimizely, which provides more enterprise level features. And if you are coming from an AWS ecosystem background, and if you are already paying a lot for AWS, you can leverage AWS App Config. And Unleash is another good product in the market. Okay, let me go to the demo. I'm not going to demonstrate anything here, but I built a simple expense tracker. Here, there are like 3 features. Both of them are like, all of them are behind a flag. The first one is dark mode toggle. So this application supports both light and dark mode. And the second one is this donut chart. So both of these features are behind a flag, which I configured in the Firebase remote config. So if I don't want these features to be accessed, or if something broke, I can turn off my features in Firebase, so it won't be displayed to customers. And also I have a welcome message, which is a dynamic value. For the moment, I kept it as a high, which is the default value. But if you want to address your local audience in your native language, let's say, how do you say hello in Thai? Huh? Sawadi. Okay, you can define that. You can define that value in Firebase and you select the country as Thailand. So if Thailand people logged into my applications, there will be that localized value there. So that's how you can play around with the remote config values. So if you want to access the live project, the expense tracker is already deployed in Firebase hosting. So you can use that. And my source code is already also available in GitHub itself. So you can go through the source code and understand how I implemented. I have implemented a couple of util functions which you can reuse. So you can access to my repository and get the source code as well. In the README itself, I have the guideline on how you can navigate to the Firebase console and create the flags. So you can make use of it. I done with the photo? Okay. Okay, now it's time for the questions. If you have any questions, you can ask now.
Cool. Some questions here in the front.
Thank you for your presentation. So I have a question. I understand the concept of feature flag quite well, but I'm curious how can I implement this in reality without actually making it work? Because, you know, let's say like you have a team, you have multiple people working on the same product, the same feature, right? And then maybe one guy builds something, new one, but then it depends on an existing function or class or whatever. Yeah, and then you need to update that existing class. And then if you enable feature flag, that might break the other. Or let's say like in another scenario where you have like multiple microservices. So if you enable and then it's break another, and then another one might be like upset.
Okay,
yeah.
I got it. So let me tell you, like at Cisco, I'm working on a project where we have more than 300 of developers working on a single project. It's called Cisco Shop, which is one of the largest e-commerce platform. So what we do is we follow the practice of flag ownership. So if a team is working on a particular feature, they are the responsible for the feature. So we also follow the naming conventions for the flags. So the flag prefix start with the team name. So let's say my team name is Vikings. So the flag name will be Team Vikings and the flag name, enable Sunday delivery, something like that. So if I look at any flag, I know that who is the owner, and they are the responsible for take that flag to the productions. So developers can play around in the non-prod environment and have their flags. Before they go to release, we have to document the stuff, when to turn it off, who have the access to the prod flags, and likewise. So you have to have a best practices on the configurations on the flags and stuff. So it's good to go.
And go ahead.
Can I have a follow-up question? So let's say like in non-production, you say you have like 300 developers, right? So I mean like using feature flag actually making the other not be able to work on whatever that they are
No,
making?
because we are like every team has a different kind of testing accounts. So we enable certain features for that email ID only. So others, it won't be visible.
Okay, thank you.
Okay.
One approach to that is that as soon as you want to change something, you leave the original version in place, and then you create a new version under a feature flag, and requests working on the new one goes to that modified one, and requests that aren't working with the feature flag one yet still keeps on going to the old one. So you can have sort of multiple teams working without interfering with each other. But what I wanted to ask is, how do you deal with non-developer dependence on feature flags? Like a product team or a customer success team, I want to turn on certain features, certain experiences for users that doesn't relate to development, but to like if they're paying for an add-on in the product, or if basically you just want to give them access to more functionality in the product.
Got it. You're saying that like the non-IT people want to configure something, right?
Right.
Yeah, exactly. So we had a carousel in our website, the platform, e-commerce platform itself. So we have configured the timeout interval in milliseconds, which is already in the feature flag platform. So feature flag is not only Boolean values, you can store JSONs, you can have numbers, strings. So we defined a number for them in milliseconds for the carousel timeout. So the business team who don't have an idea about what's happening in the back, they can configure the interval time. Similarly, we can have some banner text which they can update. The business people have access to that as well. But we also coming up back to your questions, we also have integration with Optimizely and the Slack. So if someone touches our flag, we will get notified. So you are from a different team, you go there and change the flags, or you change the audience, we will get notified. So that's how we have to have a flag ownership as well.
And just maybe to build on that question, to ask, is there some strict rule that the feature flags should generally be used only in kind of client-facing functionality, or do teams also use feature flags in the backend?
Yeah, it's possible in backend, and we also use in backend as well. Sometimes we have to route specific users to V2 API or maybe V1 API. We can use that in backend as well.
Do you have feature flags integrated directly in CI/CD? Like when someone is creating a pull request, does that automatically create a feature flag for related code?
No, so far it's not yet. I think it's possible. We have to check with some SDK or API capabilities on whether we can implement such. But we follow most of the stuff in documentation. So once we have created a flag, we define the document in whom have access to this and who is going to be the audience. So when it goes to production, the business team and the manager, they configure the stuff correctly in the production environment. Thank you. Any more questions? Yeah. I'm getting more questions, I think. Okay.
I have a question and maybe a follow-up question, so please answer the first one shortly. Would you suggest to take out the feature flags after some time out of your code, or would you just leave them in the code forever?
Yeah, it's a recommended practice to do a code cleanup once your feature is become a default behavior and it's fully working as expected and there is no any errors reported. You can make it as a default behavior, because when you're writing the logics based on the flags, there is always if-else condition, right? So once you left the company, if some developers come, so it's really hard to understand. And some platforms have the limited number of flags. So Firebase provide 2,000, but Optimizely you have to pay after you reach certain level. So in that kind of situations, you can have to have a space, right? So that time you can remove the flags that you are no longer use.
Okay, I understand. And I was curious, especially because of the complexity of dependencies of different features. How do you manage that?
You mean the large number of features?
Yeah, for example, so you have a button, the donate button, down and up, and you have the feature of, I don't know, some payment system that can be turned on and off. And then you turn on, or you put on the donate button, but haven't turned on the payment system, for example. And there's a dependency of the two.
So as I said, we follow the naming conventions, right? The team name and the feature name. So when you are like, when one feature flag is connected to multiple stuffs, so let's say you have like multiple feature flags for one feature. So that time, if you go to your platform and search that feature name, you will get the related flags as well. So like you have to have the control and when to like route the stuffs based on the previous flags. So it's always on our hand to route the flags and traffics.
Okay, thank you.
Thank you.
And just one last question, if I can. Picking up on that, is there's a certain dependency on a third party to provide the feature flag infrastructure, and obviously much like, I don't know, a Facebook Pixel or something, like you've got to make calls to that platform. You're not only getting features, now you're also getting like configurations, timeouts, strings. Do you know any platforms you can share with the audience that are open source feature flag platforms compared to the commercial solutions?
I think this Flagsmith has an open source version, but you have to self-host it. But if you are going with an enterprise one, you have to like use their SaaS.
And use their SaaS. Okay, so there's an
but there are like lot of products in GitHub which provides this feature flagging. So you can leverage that.
Take control of that. Okay, well, just a round of applause for our speaker. Thank you very much.
Thank you very much. See you maybe next year.
Thank you, Safnas. Okay, we'll take a short break and continue at 3 with the next session.
Thank you.
Yes. Oh, so okay, that's for the guy. Okay, yes, next speaker.
Am I the one only getting more questions?
Today,
Yeah, because
Today there are a lot of questions today.
Okay, let's see who that is.
I don't think I have critics.
Okay, I think we're ready to get started. If any other attendees are coming in, and let's just have a look. Oh, 3 of 5. Okay, yep, absolutely. Good. I just have. Okay, we got to stand here on stage to be on the video stream. But let's kick this off. This is kind of the cloud and DevOps track, and we're going to be talking about streamlining Java application deployments on Kubernetes with Eclipse JCube. And our speaker is Rohan, right? Rohan Kumar, a software developer from India who's working at Red Hat to try help improve the developer experience on deploying Java applications.
Right.
Round of applause, please, for our speaker.
Okay. Thanks a lot for attending this session. So let me introduce myself. So I'm Rohan Kumar. I'm a software engineer at Red Hat. So I've been mostly working on improving Java developer experience on top of Kubernetes and Red Hat OpenShift. So I work on these 3 open source projects. They are basically focused on Java and Kubernetes, binding those 2 technologies together. So let me dive right into the problem. So Traditionally, as Java developers, we are used to packaging our application into jar WAR files and then uploading it to some kind of web server. However, with the arrival of container technologies, these technologies allowed us to package our application with all of their dependencies into portable container images. However, in order to convert our application into these container images, we need to provide some kind of configuration file to these tools. But writing those configuration files can be really hard, especially when your application grows over time. And when we are talking about container technology, we certainly can't skip Kubernetes. So Kubernetes is one of the most popular open source projects on GitHub right now. And it provides really powerful orchestration capabilities for containers. But Kubernetes has a very steep learning curve, and often you need additional tools, and you need certain domain knowledge of Kubernetes as well in order to work with it. So we Java developers are used to bundling our application classes into jar or WAR files using standard build tools like Maven and Gradle. However, with the introduction of container technologies, we have some additional steps now. We need to package it into container images, and in order to do that, we need to write some additional configuration files that are called Docker file or container file, whatever you want to call it. And we have to provide this configuration to these tools like Docker or Podman, and we need to containerize it. So here is an example of this configuration file that's required by these tools. I'll just give you a brief overview. So you can see that there are certain keywords for specifying various aspects, like how to provide the base system, and what ports to expose, what files to copy, and how to start it. Very basic stuff. But this may look very simple at the moment, but this is for a very simple application. As the application is going to grow in size, these files can get really complex. So deploying to Kubernetes is slightly more involved, as you need to write some additional configuration files specific to Kubernetes. That's in form of YAML, and you also need to work with some additional tools like Helm to package those YAML files into a Helm chart and then deploy it to Kubernetes. Okay, so let me give you a very quick overview about the Kubernetes concepts. So Kubernetes has a really declarative syntax for specifying various attributes. It exposes the various aspects of deployment in form of various resources, like pod or but we don't directly use pod. Deployment is one of the most famous Kubernetes resources for deploying the applications. Service is also one of the resources that's used for exposing the applications to internal or external traffic. Config map is one of those resources to store the application data, non-sensitive data, and secret is for storing sensitive data like API keys or pull secrets. So we developers have been using our build tools to package the applications into jar WAR files. So why don't we use the same build tools to containerize the applications as well? This is where Eclipse JCube comes in. It's a tool for Java developers to containerize their applications into container images and also to deploy it to Kubernetes. So it helps the Java developers getting started with these container technologies. It's really opinionated in nature, and it's great for prototyping things. Certainly, when you're working with these technologies, you definitely need to know how these works. But when you're starting with these technologies, it can be really overwhelming to work with these technologies. So JCube tries to make this step easier by quickly letting you get started with it. So it tries to simplify things for Kubernetes, like it creates the container images for you by inspecting the project dependencies. And it also creates the Kubernetes resource manifests automatically by checking whatever the dependencies you have. And it also provides support for creating the Kubernetes Helm charts by packaging the generated Kubernetes YAML files into a Helm chart. Okay, you can use JCube so it's a tool for your build tool, right? So you can add it as a plugin in your project dependencies. If you're a Java developer, you must be familiar with these build tools, Apache, Maven, and Gradle. You can just simply plug these plugins into your project, and you can just get started with it. One of the special features of JCube is that it's really opinionated. It has this thing called zero configuration. You just plug it, and JCube is automatically going to detect what kind of framework you're using, and it's going to generate opinionated container image manifest for you. Of course, that can be configured, as per your requirements. So it's really great for, so we have support for almost all of the Java, popular Java frameworks like Spring, Quarkus, Micronaut, and Eclipse Vertex. And there are many more, but I just listed some popular ones. So here is a diagram for, so it's the combined version of what we saw in the previous slides. So with JCube, you can do all of those container containerization steps with the help of these JCube build actions. So there is an action for building into a container image. There is for pushing it to some registry, and there is the create resource action to create the YAML manifests. There is Helm action for packaging it into Helm charts, and basically to simplify the process of containerizing the application. Okay, so I have a recording. It's a very short recording. Could you please make it full screen? So I'll be deploying a really simple application to Kubernetes with the help of JCube. So, okay, so I have in my IntelliJ, and I have developed a really simple to-do list application using a project called Quarkus. It's a popular framework for writing cloud-native applications. I'm going to scroll down, and I'm going to check check whether I have added the plugin. So you can see that I have added the JCube plugin here, Kubernetes Maven plugin, and there is an additional OpenShift Maven plugin as well. But for this talk, we are only going to focus on the Kubernetes Maven plugin. Okay. All right. So let's go ahead and deploy this application to Kubernetes. So I'm going to switch to my terminal now. So I'll be deploying it to Minikube for demonstration, and we'll be checking the status of our Kubernetes cluster with the help of Podman Desktop. It's a tool for developers to see to test the containers in their local environment. It's a CNC project, so yeah, So I'm going to start by packaging the application into a jar file by using the standard build ambient clean install. So this should build, it's very standard. It's going to build the application classes into a jar file that should be accessible. Yeah, application is packaged into a jar file. Now let's go ahead and package this jar file into a container image using the JCube's build goal. So we are going to do the ambient KTS build. It's going to inspect the project dependencies, and it's going to create an opinionated container image out of it. So it has created the container image. So let's go ahead and inspect it. All right, so you can see that there is a container image that was created 8 seconds ago. Let's quickly go ahead and run it to see whether it's running or not. I'm going to copy the SHA and just run it with Docker. Yeah, we can see the application logs, and we can see the Quarkus logo. Yeah, it seems to be working fine. So without any additional step, we could quickly containerize it and just run the application. Let's go ahead and create the Kubernetes manifest for our application. So for that, I'll be using the KTS resource goal. It's going to inspect the project, and it's going to add whatever is required for deploying this application to Kubernetes. And it has generated it. So let's go back to the IDE and check where it has generated them. It should be in the target folder, and you can see that it has created a deployment. You can see that it has added a lot of stuff, and it's quite opinionated in nature. So it has created all these resources, and it added some additional things as well. It already knew which ports to expose by checking the application properties. Okay, so let's go ahead and apply these generated resources to our Kubernetes cluster. So let me just adjust my Podman desktop view so that we can see the application is deployed or not. So let's go ahead and apply these using the KTS apply action. So it's going to just apply these YAML manifests. Okay, so application seems to be available now. Let's go ahead and access it using, let's try to go ahead, copy the link and access it via browser. Okay, it's available now. So application seems to be running. It's a very basic application. Just I'm going to add some simple to-dos like buy groceries and water plants. Yeah, go for walks. Yeah, it seems to be working. So there is there's a different way to do the same thing by instead of applying the manifest directly. First we are going to undeploy the application as well. Once you are done testing, you can undeploy it using the undeploy goal. We can do the same steps similarly using the Helm approach. We can package the application into Helm chart and then apply it using JCube. So we are going to use the Helm goal for that. So it's going to package the generated Kubernetes manifest into Helm chart. Helm chart is the default packaging format in Kubernetes. So people usually package them into Helm charts and then use it. Yeah. So if you apply this Helm chart using Helm, you should be able to deploy the application. But in JQ, we have a goal for that as well. So we are going to just run the K8s Helm install goal, and it's going to apply the Helm chart onto Kubernetes. Yeah, you can see that application is running. So I'm going to do the same thing. Just try to access it. Okay, it seems to be available, and I'm going to just add some more to-dos. Yep. All right. Yeah, that's really important. Okay, so yeah. Okay, so application seems to be running. So this concludes the demo. Could you please minimize it and all right, so that was pretty much for the presentation. So what I just want you to remember of this talk is about JCube. It's a tool to containerize Java applications and deploy them to Kubernetes. It works out of the box for most of the popular Java frameworks, and it's focused on Java developers transitioning to container technologies. If you're interested, you can scan this QR code to reach the project URL. So yeah, that's pretty much it. Thank you for your time.
Nice. Question. Okay. Any questions from the audience on this? I mean, it's amazing to see Eclipse still going strong after 20 years of R&D. I mean, that was back at university almost 25 years ago. Okay, any questions? JCube deploying over there?
So I have a question regarding, so you used Docker commands over there, right?
Just to access the container image that was created by JCube.
Okay, so instead of that, is it possibility of using Podman as an alternative to Docker? Because
Definitely.
Yeah, okay.
So just to mention, JCube does not rely on Docker, or it just needs access to a daemon. We don't rely on any kind of CLI tools for doing all of those things that I showed in the demo.
Okay. Any further questions to the speaker? Wrestling with Java and making progress in moving towards containerized infrastructure. Yeah? Okay, great. Thank you so much for that presentation.
Thank you very much.
Appreciate it. Thank you, sir. Nice to speak. Okay, Ritik, Roy. Yes. Okay. Just see, we're a bit ahead of time. Bring it up. So your session's supposed to start at 3:20.
Oh, okay.
Yeah, so you still got 5 minutes.
Extra?
Depends if you time. Like a rush?
No, it's not rushed. It's calm, composed. I can wait as well.
15 minutes. I think we wait a few minutes, so because also with the web stream.
Yes.
I'm sure you're very nervous. Just calm down.
Yeah. Thank you.
try and make it. Okay. We'll have to give you like a part 2 slot. And, you know, the demo, and today's already last day.
Next class. No, different areas of India. We met over here.
Oh, I'm over here, but you're all different areas of India. Cool. Yeah. It's streaming, but I don't know if they publish.
Streaming to YouTube.
That's a live stream.
Yeah.
Is 15 minutes until 35, right? And then we've got this one. Okay, so but this
First one is 15.
yeah, so this is but this is 320 plus 15 is 35, and this one is 45. A minute break. Odd. Okay, then we got another 10-minute break, so it's basically out. There's no tea break in between? Okay.
Or maybe that 10 minutes free.
Yeah, maybe we'll do that. Okay, we get ourselves up on stage.
Yeah, sure.
See if people still come in.
What's the time?
It is 3:20. And you got 15 minutes, and then there's a 10-minute tea break. Maybe we'll just push the door open to leave the door open. Stay for a while. It's working.
Yeah, it's good.
And you got the laser also if you want to use the laser. Oh. Cool.
Hey, hi.
Okay, I think Ritik is ready to give us a performance. Okay, let me introduce Ritik Roy, platform advocate at Loft Labs from India. And so he likes to create an impact on communities, either by part of coding or content or mentorship. Ritik is going to give us a presentation as part of this DevOps and cloud track, about 15 minutes, also on multi-tenancy made simple, what it is and why it matters. Can I have a round of applause for Ritik? Thank you.
So, hi everyone. This is my second time in FOSSASIA. I was there last time, and I was very excited about this event. So last time I talked about cloud development environments, but there is a overriding problem about how we can save cost and how we can have multi-tenant architecture. Before I start, a bit about me. I'm Ritik Roy. You can connect with me at Ritik here. And I'm a platform advocate at Loft Labs, a CNCF ambassador. And I've done a couple of certifications, and I like talking about things that interest me. So today, when we talk about multi-tenancy, Kubernetes, and all those areas, we need to understand what Kubernetes is. So first important thing we understand is it is the abstraction layer. And apart from the abstraction layer, it is more about cost abstraction as well as compute abstraction. So you abstract away your cost because all of the things you are creating is created on parallel as well as compute resources as well. So as a large-scale distribution system, wherever a cloud company comes into the picture, they care about making it simple. The reason being, each node is a revenue generator. Apart from that, each control plane, like the control plane cost you pay, is also a revenue generator for them. So most of the cloud providers and most of the providers focus on making it as simple as possible. So right now, you can go and spin up a cluster with hundreds of nodes, and it is as simple as that gets. But there is a problem with that. The problem is, now, if it's so simple, you can have a cluster for every customer, every team, every member, and that creates hundreds of unnecessary clusters. With so many unnecessary clusters, there's a cluster toil, and we need to consider a couple of more things over there. The first thing is, suppose you have n number of cluster per team, per developer, per department. There are two types of costs we care about over there. The first is the cost to run the hardware, and the second is the maintenance cost. As your number of clusters scale, both of them scale together. Like for example, if you have hundreds of clusters, you pay the cost to run those applications. Like for example, if you are running Argo and all, you pay for that. But apart from that, you pay for things that are running again and again. Like for example, cert manager across all of your clusters. So as you see, there are a lot of costs associated, but there comes something called multi-tenancy in the picture. So if we talk, it's like multi-tenant city, if you break down it to the lowest level. And to explain what is that, I have a simple example for you. Suppose you live in a flat. What we do over here, you have resources that are managed by your flat provider, as well as you have all those abstraction layers of security and everything. You don't care about that. Your tenant cares about that. And you can go and stay in your flat. You can have all those resources, and you don't need to manage most of the plumbing and all those things. On the other hand, we have a home where there are a couple of problems. The problem is, suppose you are renting it. You need to create new doors, new parameters and everything. And apart from that, you need to manage your own plumbing. You need to manage your own electricity. So as you see, there are two domains. At one place, everything is managed, but it's less secure. On the other place, where you have a home, your things are smoother, but again, you need to have stronger abstraction layer if you are allowing anyone else. So whenever we talk about multi-tenancy at basic level, we talk about three specific categories. One is workload isolation. So you want your workloads to be isolated from each other. You don't want your customer data to be moving from one to another. Tenant autonomy. Whenever your tenant is running, you need to have the full permission for them. It's not like that your tenant can't have privileged permission inside of your cluster. And last is fair usage. You don't want your single tenant, maybe it's a team, maybe it's a customer, maybe it's anyone else, to consume all the resources you have. All those pillars are important for you to perform in a multi-tenant architecture. And when we dive deeper into this, there are a couple of ways we can approach this. So before we approach the ways, let's understand the definition. So it's a big definition, but at the end, the goal is to share a cluster or share an environment between different teams or between different resources or between members. And currently we do it in two ways. The first way is focusing on namespaces. So how many of you have heard about namespaces over here? Kubernetes namespace, one of the most basic Kubernetes resources. So it's a simple resource, and a lot of things are not isolated over here because you are just creating a virtual abstraction. You can add a lot more things over here, like IP blocks and everything. But suppose you are deploying a CRD. What do you do that? It's a cluster level object resource. So you can't isolate that, and that is the problem. But apart from that, there are other problems as well. These are the list of problems. Like for example, as your number of tenants grow, you can create n number of namespace, but how do you manage the conflict between different CRDs? And then how do you distribute different Kubernetes config per team? It's a single config, you can add a lot of layers and everything, but again, you need to give the access to your config. And suppose one of the config is exposed, then how do you make sure that all of your environment is safe? So generally, namespace isolations are good when there is trust in the tenant, but apart from that, resource sharing and everything is hard to manage. And when you have growing number of customers whom you are sharing a cluster with because they have their environment running over there, it's complicated. Then the next thing is, the next type of multi-tenancy is where you create different clusters. But the problem is here is the cost. So you can have n number of cluster, but with n number of cluster, you pay n number of control plane cost, like the cost you pay EKS for running your clusters. The platform stack cost, for example, you're running cert manager one time in a cluster. You need to run it 100 times. So it's 100x the compute cost of one cert manager. And the last is workloads. Workloads are similar cost of how many times you're running. So that doesn't matter that much. But apart from that, the most important thing when your teams are growing, the complexity grows. How do you make sure your clusters are being killed when it's not being used? How do you make sure your cluster is as simple as possible for your administrative layer to manage? It's hard. And the most important thing which we have noticed when we were experimenting about this technology was, as you are distributing your workloads across different geolocation, billing and tagging becomes very difficult with more clusters. So what do you choose? Like, do you choose namespace? Do you choose clusters? How do you create a multi-tenant architecture in your system? So the approach which we came up with was segregating your platform stack and having a virtual cluster. Like, as we have a virtual machine, which is using a hypervisor on top of your cloud infra to create virtual machine, we use the same approach to create a virtual cluster. And the way we do this is open source virtual cluster. So we are an open source GitHub project with 10.5 thousand stars. And we are focusing on a specific multi-tenancy problem. And the problem is, you can scan the code to go to the website. But the problem is as simple as that. So we create a host cluster, which you bring in. It can be EKS, it can be your GKE or anything as such. And then what we do is we create a namespace and make sure we enforce the isolation layers. Everything is stored over there, and your applications and everything, including CRDs, are synced back to the host cluster. But the advantage is you are not creating more infra. You are using the same infra. It is as simple as deploying a namespace, but you get the advantage of having stronger isolation control. You can isolate your networking layer, you can isolate your CRDs, as well as you can isolate your storage provisioners. So as you see, you are having virtual clusters. And if we go back over here, like in a simple example, you run your cert manager, Vault, Argo, all of those things again and again. What you can do is save the control plane cost by moving all of those repeated platform stack at one place and creating your virtual cluster and all those components inside each of the weak clusters. So what you get is simplified Kubernetes cluster management. But apart from that, the best thing is like you can sync your resources. For example, if you're running a vault, you want to sync the secrets and everything, or if you're running an ingress controller and you want to sync your ingress classes and ingresses up and down, that can be as easy as just configuring that into a YAML. So as you see, your administrative layer is doing all those things, but as a developer, you just focus on building, deploying, and running, and doing the most important part of your job is creating business impact and value. So whenever you think about vCluster, what you get is you bring in a simple layer of your host cluster, and you can have multiple virtual clusters on top of that. Most of the times, whenever you need a cluster in your org, the problem is you don't have enough access in the cluster because it is divided, and it also takes a lot of time to get it. So with the full cluster admin access in top of your virtual cluster, your team can have a host cluster, and you can have all those virtual clusters identifying and deploying things. The third part is we use a lot of CI and all those things. And the problem is it takes time to deploy Kubernetes, and it wastes the action minutes and all those things. So as it is creating a namespace only, so it deploys as fast as a container. So whenever you are using that, your CI pipelines can be faster. And then the couple of capabilities is like you can choose what type of isolation you want. Do you want to isolate all of your resources? Do you want to isolate all of your networking? Do you want to isolate all of your storage? So that is the power you have. Next is self-service. The goal is to, like whenever we talk about user experience, it is a popular goal. But whenever we talk about developer experience, most of us don't care about it. So the goal is to improve the developer experience for developers so that they can come in, request a cluster whenever they want, test whatever they want, and then go forward to do their work. Last is, whenever we think about vCluster, a way to create quick clusters, what can be a few use cases? First is quick CI. For example, you have a virtual cluster in top of your pipeline, and with that, you can create quick CI so that your testing and everything can be done easily and faster. Next is testing environments, full-fledged testing environments, which mocks your real environment. That can be done because you configure everything in a YAML. Last is environments with different CRDs. As we were discussed, you don't need to go and create new CRDs every time for every cluster, for every environment. You can have virtual clusters which do that for you. And last is, whenever you have a node pool and you want a specific team to have specific type of Kubernetes compute resources, you can specify that, and your virtual cluster manager, which is vCluster, can issue those type of nodes to those type of clusters, and then you can use that. Nextly is, this is about me, so you can connect with me and learn more about what we are doing. And if you have any questions, we have some time for that. Feel free to ask me, and I will be here.
Yes, absolutely. We have some questions. Oh, we have time for questions. Over there.
How you deal with performance if provision multiple cluster, it would create the overlay network or not?
Yeah, so the way we, it goes back to the architecture layer. So what we do is, we don't create actual clusters in top of your cluster. What we do is, we create a virtual namespace, and then whenever you create a networking layer or pods or anything, we sync back that to the host cluster with some labels and everything, so that whenever you are using, there is no bottleneck. For example, if you are using a etcd a server on top of your host cluster and it's getting thousands of requests because you are creating a lot of secrets. With virtual cluster, you will have dedicated API server for each of your whole virtual clusters. So the requests will go through them, and it will actually underburden the host cluster. And then again, there is a syncing capability. For example, if you have ingress in all of your hosts and virtual, you can sync whatever you want, so that to balance out your burden. Yep, thank you. And any other questions?
Was there a question at the back somewhere? No? Oh. Yeah, happy to take one more. Otherwise, I think we're good, and that was informative. Thank you very much.
Yes.
Oh, one more. Yes.
Can you just please repeat the question?
Okay, if we want to run the cloud FinOps to like kube cost, can it measurement on the?
Yeah, we have an integration for KubeCost as well. So it's in the open source version as well. So you can integrate with it. And then we are building an internal Cube dashboard so that you can measure the cost you are saving, both on the platform stack, both on the stack of how much cost you are saving by using virtual control plane instead of the actual control plane from the cloud providers. So that can be done. If you are more interested, I can help you to learn more.
Okay. Thank you.
Thank you so much, everyone, for having me in my talk.
Round of applause. Okay, good. So we're going to have a pause now until 3:45. That's about 10 minutes. So anybody who wants to stretch their legs or get some refreshment, and we'll kick off with Parth. Hi, Parth. Okay, good afternoon. We're good to go on to our next session. It's going to be a 20-minute presentation on optimizing IP address management with open source CNI plugin. And this presentation will be given to us by Parth Goswami, a custom enablement engineer at Cloudera. So he's an open source enthusiast and works mostly with containers and networking. And he loves contributing to open source and hosting meetups and interacting with the community. So thanks for being here. Parth, over to you.
Thank you.
And a round of applause.
So we are almost at the business end of this event. So I hope you have had a good conference so far, good, fruitful, and productive. I am not habituated with mics, so yeah, I'm gradually getting habituated. So please excuse me and bear with me if my pitch drops suddenly or there is a spike. All right. So I work for Cloudera as a customer enablement engineer, and today I'm going to talk about adapting open source CNI plugins for IPAM. Before I start my talk, I wanted to understand, like, how many of us are students over here? Can you just, with a raise of hands? All right. And how many of you have some sort of networking background, like work with platform networking or container networking? All right, cool. I see few hands. That makes my job easier. So again, before I start my talk, I just, based on my experience, again, don't quote me on this, but what I've seen is students usually stay away from networking. They try to skip networking. Maybe they don't see the value in it. They run away from networking for so and so reasons. And networking is one such aspect that gets left behind, right? Now, if you try to start at the very bare metal level and then go like above the bare metal level, that is your hypervisor is there, and then top of that your virtual machines are there, and then if you are in the microservices environment, on top of your virtual machines you have OS and then the container layer, and then if you are also orchestrating that, you have another orchestration layer, and then finally you have the pods and the containers inside, right? So the one aspect that would bind the entire stack is networking. So networking is something that's very important, very essential. So this is a very small attempt from my end to simplify networking and to ensure that that we understand networking to its core. So the approach that I'm going to follow is I'm just trying to break down these heavy words, heavy terminologies. So I would assume all of us to be very much familiar with the first two words, adapting open source. Now, I'll start by defining what CNI itself is, what plugins are, what IPAM is, and then we'll try to understand why there is a need for adapting open source CNI plugins for IPAM in the Kubernetes space. All right, so this is the agenda. I'll maybe skip that in the interest of time. All right, so let's start with the definition of CNI. This is the definition officially given by CNCF. That is, it is a specification, it is a specification that defines how to configure networking for Linux containers. The way it does that is by providing APIs for networking solutions to be integrated with container runtimes of your choice. So it doesn't matter if it is a X container runtime or a Y container runtime. It can be anything of your choice. And so just look at this diagram and try to picture this diagram from the bottom-up approach. So you have container runtime at the very bottom, the layer, the container runtime, and then on top of that sits the CNI layer, right? And then the CNI layer ships a lot of plugins with it. Those are, some of them are inbuilt, like we have loopback, bridge, MacVLAN, and then most of them nowadays are third party, and it is essential for the clusters, for the enterprises, for the administrators, to network admins basically, to use third party network plugins. Now this talk entirely is designed or the attempt is to understand the need to go towards third-party plugins, and there are various lots of purely open source third-party plugins available, CNI plugins available. So yeah, eventually we'll try to understand why there is a need and what all options we have in the market today, so that we can make better use of those CNI plugins. All right, so if I were to start with a very basic concept of CNI, and if I were to establish a network within my own container, the very first thing that I need to do is I need to come up with a network namespace, right? So I believe the last speaker in his talk talked about or touched the point about namespace. So just wanted to open up this question, if anyone can define namespace in its simplest term for me. Like, what is a namespace? And it's a Linux term. It's not a container devised term. All right. So let me try to explain the term namespace in a very layman term. So we are in this True Digital Park on 3rd floor, and then we are attending this talk in this definite area. Now, if there is only just one talk happening on the entire 3rd floor and we want to conduct another talk, we might have to move to another building altogether or maybe another floor, but that's not efficient way of running things. So what we did, we created physical isolations by creating barriers, and then parallelly, concurrently, we are running multiple talks on the same floor. As of now, to be precise, there are 5 talks, right? So the intent is to not let this talk interfere and influence any of the adjacent talks that are going. And the way we are doing is, we are just creating barriers, physical barriers, big tall barriers, and then every small section, every small segment is being powered by all the necessary things. A stage, a podium, mic, the setup, screen, etc. And then this is replicated in all this isolations, right? So in the Linux term, because you have multiple processes, multiple applications running simultaneously, concurrently, there is a high chance that if there is no isolation provided, they might start interfering or influencing the adjacent concurrent running processes. So how do you ensure that they are not doing that, right? So you create namespaces, you isolate them, you segment them, and then you create virtual isolation for them to run concurrently and simultaneously. So when I'm doing that, what exactly I'm doing is I'm creating separate usernames. Every namespace will be having its own username, its own file system, its own SE Linux policies, its own network policies, its own security policies, its own usernames, host names, right? So all of that thing. So building upon this concept, this namespace is not just required for applications or for processes, it is also required for the network as well. So at the network level, we create network namespace. Again, I might want one application to be running in one particular subnet of my topology, and another application to be running in another subnet. So instead of creating multiple pods or containers, how about I just go and create multiple network namespaces. So similarly, every individual network namespace will be having its own NIC, network interface card, will be having its own socket, port, IP table, rules, firewall D, NF tables, etc. And then they will be running on different protocols within the same container, right? So in order for me to establish a network within a container, the very first requirement is to be able to create a network namespace. Then once that is created, the CNI should be able to create a bridge network between the host device and the container device. And then once the bridge is created, it should be able to create Ethernet pairs, right? So again, the Ethernet pair, one end of it is connected to the bridge of the host and the other is to the container end. And then why virtual? Because we are at the container level, nothing at that level can be or will be physical. So even the network, even the Ethernet cards or the network interface card would also be virtual. And then once that is done, you attach a virtual Ethernet to a namespace. And so you attach the other end of it to the bridge and assign the IP addresses. And once the IP address is assigned to a particular pod, to a particular container, that is when the container comes up and the pod goes live. Now, okay. So before that, this is a sample code, a sample algorithm, right? Now this requirement is there for almost every known major standardized container runtime interface, right? So be it Docker, RKT, Mesos, Kubernetes, Cryo, you name any CRI. So every CRI would require some sort of standardized code or standardized algorithm, and then this code, this standardized, if we try to create a standard out of it and start shipping with every other CRI, That is called as plugin, right? Now, if I were to create my own CNI, which is very much possible, my CNI should be able to play certain roles which are most mandatory, which something that the CNI cannot skip, right? So let's try to understand a very finite, non-exhaustive list of such roles. The first is it must be able to create network namespace. We understood what exactly a network namespace is in great detail in the previous slide. And then since there will be multiple network namespace, it should be able to identify the correct namespace for a particular container, and it should be able to attach the container to its proper network namespace. And then it should be able to invoke the network plugin whenever a container is added or whenever a container is deleted. And yeah, so again, whenever I'm configuring something, I would be configuring it in terms of files. So it should accept a proper standardized format. JSON is one such format. You can go for any other format as well. And yes, one important thing is it should be able to support CLI, because I, as a network admin, should be able to, or developer, I should be able to interact with the said CNI. So it must give me some accessibility, some way to interact with and perform at least the three most major important operations, that is add, delete, and check. So add as in add the container to the network namespace, delete as in terminate or remove, and then once I have added or deleted, I must verify, I need to be able to verify whether the said container has been properly attached to the network namespace, and hence for that there should be a check operation as well. And then once that is done, it should be able to return the results in a specific format. Again, it can be text, tabular, JSON, whatever it is. So before moving on, a quick recap for all of us. I assumed there would be students, so just try to create the slides accordingly. So as of now, what we have seen is the definition of CNI. Quickly, it is a specification that defines how to configure networking for Linux containers. A collection of a sample algorithm or a code is nothing but a plugin. And then examples of plugin that we saw in the diagram were like Bridge, IPVLAN, and some of the other third-party plugins that we'll touch in the later half of this Demogen's slide. Okay, moving on to the second topic, the second half of this talk, that is IPAM, IP address management, right? Now, if you are doing any business that involves assigning IP address to a container, revoking IP address to from a container, managing, monitoring, tracking IPs, you are basically dealing with IP address management. You are dealing with basically IPAM. Now, in this particular slide, I'm not talking from the Kubernetes perspective. I'm just trying to define IPAM from in a plain, simplest networking vanilla possible way, right? So yes, so if you're doing anything or touching anything with respect to assigning, revoking, tracking, monitoring, managing IP addresses, it is IPAM. If you think, or if you are in a notion that there is a device, you attach an IP address to it and just go about your day, that's not enough. No, sir, that's not definitely enough. So if a device or if a container is terminated, there should be a methodical approach, or there should be a systematic approach or a defined set of steps that the IPAM should function. For example, if the container is terminated, the network admin must ensure that the IP address has been revoked and properly sent back to its IP address pool, and it is not reused before it is thoroughly cleaned up, right? So all this set procedure should exist, and for that reason IPAM should be adopted. And yeah, so IPAM also is an integrated suite of tools. It integrates DHCP and DNS as well. Now, from the Kubernetes perspective, let's try to understand what IPAM exactly, whether it exists or not. First of all, whenever we are talking about Kubernetes, we're actually talking about orchestration, right? So we need orchestration because the number of pods and containers grew beyond our control. The very reason that we are now dealing with tens, hundreds, thousands, millions of containers is the reason that we are required to orchestrate them. There are pods. Every pod will require an IP. Every service will require an IP. when a pod tries to interact with other pod, it needs an IP. When a pod tries to interact with a service, it needs an IP. When a pod tries to interact with the external network, it needs an IP. Apart from pods and services, there are other resources within Kubernetes that require IP, right? So there is a high need of IP address, and whenever there is there are many multiple million factors of containers and pods. So there should be, again, a need to manage, track, allocate, revoke, monitor those IP addresses. So Kubernetes has a built-in tool to be able to perform IP address management, and that is kubeproxy. That is a built-in tool that comes by default, but it comes with certain limitations, right? So what those limitations are, like the kubeproxy is not in a position to scale beyond a certain level, right? So it has a load balancing capability, but it's not smart enough in the sense that it does not look after the pod's health or pod's load and then divert the traffic. So it has certain limitations. Now, there are some challenges given by or possessed by the IP exhaustion. So back in 1980s, when we came up with this concept of IPv4, we divided the 4 octets into 8-bit each, 32 bits, and that gave us about 4.3 billion IPs. So by 1980s, it seemed that those many IPs would have been sufficient, but in next 10-15 years, it was very clear that those many IPs would not be sufficient because by 1995, 1990 around, we understood one important factor, that IPs are not assigned to users, they are assigned to devices. One user can handle multiple devices. Look at your phone and your device and then just try to understand how many IPs are assigned to your Ethernet or NIC, and then you'll be amazed. So every single user is handling multiple IP addresses extrapolated to the level of the cluster, right? So IP addresses, it was very early identified that they would be limited in space. So there are a lot of challenges when it comes to IP address exhaustion. First is network congestion. If my pod is ready, but IPs are limited, they would try to fight and there would be a race condition, or maybe the network admin might be tempted to reuse the IP address and assign it to an upcoming pod. But the previous pod was not terminated cleanly, so there is still a live access to the previous pod's sensitive info, right? So that also possesses the security risk. And then if my resources are enough, if my pod is ready, but IP addresses are not enough, my pod would not go up, my container would not go online, and that is also another factor that would contribute to difficulty in scaling. And then increased complexity with less number of IP addresses, network admin may try to or may be tempted to adopt complex ways to as a workaround, for example, overlay networking or maybe multicast IP addresses, right? So or maybe NATing. So this definitely introduces some complexity. So as a result, Kubernetes tried to throw in some built-in plugins. The first one is host local. Host local, what it does is it basically allocates the IP addresses locally. It is good for a small scale cluster, but not for an enterprise level large scale cluster. Again, DHCP is another built-in plugin for IPAM, but the thing is that DHCP would require its own DHCP server, which again comes with its own overhead, right? So it is an overhead if we are supposed to manage another DHCP server. So I personally wouldn't want any such overhead. So given these limitations with built-in plugins, Kubernetes finally started supporting third-party open source IPAM plugins. So this is some of the glossary of those or collection of those plugins. On the left-hand side, these are some of the built-in plugins that are shipped locally by Kubernetes. And then on the right-hand side, these are examples of the few completely open source CNI plugins. We'll start with Bridge. Again, it's been adopted or fetched from the Linux terminology, and it tries to create communication between your host device and your network and your container network. Host local, again, it tries to assign IP addresses locally. MAC VLAN is something that would uniquely try to assign a MAC address to a particular container so that it would communicate as if it is a physical device. IP VLAN is working similarly as Mac VLAN, but yeah, but it uses less resources in terms that it uses same MAC addresses for multiple containers. And then loopback is very essential because many applications are coded in such a way that they assume that there is a presence of loopback IP address. So that is required. Static and DHCP, they assign dynamically or in a static sense. Now there are some of the examples of third party. Flannel is a lightweight option. If your cluster is lightweight, if your cluster is small scale, Flannel should be a good option. Calico provides networking and security solutions. And then again, there is another third-party network plugin that is called as Canal that combines the capabilities of your Flannel as well as Calico. And then there is Cilium. It uses eBPF at the backend for high performance. There is Weave for mesh networking. There is OVN Kubernetes. It is called as like Open Virtual Kubernetes to provide advanced networking features. And then there is SRIOV for improved performance or for high performance. Again, this is not an exhaustive list. There are much more open source CNI plugins coming up in the market. So yeah, based on your use case, based on your network topology, based on the architecture, and if you are very much concerned about your performance, you have certain options. If you have a small cluster, you have equal options. So yeah, so that was about it. And then there's a recap. And yeah, I'm Parth Goswami. I work at Cloudera as Customer Enablement Engineer and been working with in the networking space for a long time. Thank you so much for the talk.
Thank you, Parth.
Yeah, any questions?
Have time for some questions before we get to the last session of today. So welcome anybody, any questions, networking, IP address management in the virtual environment? Yep, over here. Thank you very much.
Thank you for the awesome session, Parth. I really got to know about networking more detail because I was really confused basically about the networking. It is like a network in the head basically, and it is all get exhausted. Thank you for that. I just had a small question, like how someone can decide which CNI plugin is suitable for their architecture, or maybe while deciding the CNI plugin suits for their entire portfolio.
Again, I would recommend to start by looking at your topology, the number of devices, the use, the daily use cases of your containers, as in how many containers are supposed to come up in a specific day or over a weekend. And then based on that, if you require high performance for a specific time but okay performance for a long time, based on these factors, you can decide. I won't be able to like advocate a particular name, but yeah, based on such factors, try to question yourself and then try to look at the features of all those plugins one by one, try to have a comparative analysis, and that is how I would decide a best suitable plugin for my architecture.
Yep, sure. I have some follow-up. That answers best thing, but can we use multiple CNIs for the internal containers and then external applications or something like that? Like we can get the best out of that, right? Because sometimes some organizations has partnership with some of the third-party providers, network providers basically, and that leads to themselves to not exhaust the current IP addresses quota assigned to themselves. So instead of that, we can use the open source one for the containers. Is that possible?
Absolutely. The major proprietary solutions, networking CNI solutions, the major proprietary CNI solutions, they often ensure that you're vendor locked. You're not allowed, or maybe they make you design your architecture in such a way that you are not supposed to talk to any other third-party CNI plugin which is not designed by them. That's the reason this is an attempt to throw some light on the open source options, which are definitely very flexible and allow you to interact with multiple CNI plugins from third-party, as well as, again, you can use some of the already existing, already inbuilt shipped plugins by Kubernetes as well. So in open source world, that's definitely a big yes.
Okay. Thank you.
Okay. Sounds like there'll be some more conversation on that. But yes, if no other questions, we'll close out here. Oh, one more as a follow-on. Yeah.
Yeah, you asked, can we use multiple? Mhm.
Vendor lock-in is like there present. There is a vendor lock-in actually. He mentioned about that, and that will lock ourselves. So he said that at the end that you can use the open source alternatives for that, and you can use the mixed ones, I guess. The default one is there, right? So you can implement default ones, and for the application you can use the other ones.
Yeah, and then most of them can be used internally as well. Yeah, yeah. And then you always have the ability and flexibility to come up with your own CNI. So in the one of the list I mentioned the must necessary roles that the CNI must play. So like, if you're just following that and try to keep it simple, you can definitely come up with your own CNI as well.
Okay, networking can probably keep us busy for a few hours. So we'll take that offline. But thank you very much, Parth. Appreciate your session. All right, and we'll have just asking our last speaker to come up to kick us off right away, which is Viet Nguyen.
I might need a slide for last. You have 15 minutes. I will stay here showing you how many time we have left in this site.
I want to double check.
You have the slides?
Yes.
Yes, you have given to him?
Yes.
He's uploaded. Viet Nguyen Duc.
Oh, just call my first name. Viet. Viet, yes.
Viet. All right. All right, while we get the slides up, this will be our last session, talking on browser automation at scale with Selenium grid autoscaling in Kubernetes. This is part of the cloud and DevOps track, and it'll be a 15-minute talk by Viet, a software quality engineer at TMA Tech Group, and he describes himself as a passionate software quality engineer. So a round of applause for Viet, please.
Yeah. Hello, everyone. The first time I have come to Thailand, and today I would like to share about one interesting topic about the Selenium Grid. I think most people already know about Selenium Grid. Recently, they released the version 4 with new function that can deploy in distribute mode, and how Selenium Grid can integrate with other DevOps tools like Docker, Kubernetes, and now it can auto scaling with the KIDA, and also we can deploy the whole ecosystem with the Helm chart. So before This is a little bit introduce myself. Currently, I also a contributor for the project Docker Selenium. So today I will work through all the detail, my contribution there. So the overall data, I will introduce a little bit with the Selenium capability. Then the detail how the grid auto-scaling in Docker and how the grid move on the auto-scaling in Kubernetes. So here is a little bit introduce Selenium grid. It's a core component belong to the project Selenium. And the capability of grid allow you to run your web driver code in remote machine. It can run parallelly in multiple node machine with multiple platform and multiple browser. So get started with the grid is very simple. You need a machine. It can be your laptop, your virtual machine with any platform. You install Java and then you download the Selenium server jar from the official Selenium website and you start. Beside that, you also need to install the browser there. So, but with this deploy in local, it's suitable for you to start in deployment. For example, you are a developer, you want to test something, but when we come to a large scale test infrastructure, we support another deployment type is using Docker. We build some Docker image. The Docker image is grab, includes Selenium server and the browser installed there, which using the platform is currently is Linux by Ubuntu. So you can choose two options. First is standalone. The standalone is the single image with Selenium server and the browser there. And the second mode is node and hub. But the difference is in your code. For example, you deploy the standard with Chrome browser, you run on board 4444, or for the Firefox, you run on another board. So you need to switch the UI upgrade in your code. For example, with the node and hub, you can deploy multiple node browser there, and you just worry about a single endpoint. And here is the list of Docker image that the project Docker Selenium we deliver to the community. We deliver the group of image for standalone mode, the group of image for node and base, and the group of image if you want to deploy full distribute. Here you can see the list of full distribute from the hub component. So here is the diagram that how Selenium grid auto-scaling using in Docker. We deliver a component called the node Docker, where when any request come to the hub, it will distribute based on the capability. For example, the test request to run on which browser, which platform. So it will route the request to the node Docker, and in the node Docker, it will communicate with the Docker daemon to spin up the node browser. For example, here with this diagram, I'm using 4 virtual machines. For example, with the first host, we only deploy any request route for the browser Firefox. For other browser, we can route it to another host. So based on based on the capability of the host, we can set the maximum section. So that's allow us to control the maximum of node can be spin up, adapt with the capability of the VM. So in the last diagram, we see it look like with Kubernetes. So our the Docker image that we deliver can deploy it to Kubernetes cluster. So now the browser nodes, it will run as a pod in the cluster. So we take the advantage. We take the advantage of Kubernetes SPA horizontal pod autoscaler. So, but the SPA is had one limitation. Is rely on the metric in CPU and memory, but the grid we need based on the event. For example, we need to count the requests in the queue, and we spin up the node. That's the node that is matched with the capability of the request. So we rely on another kind of scaling. IKIDA is stand for Kubernetes event driven autoscaler, and this is an open source project. We rely on KIDA, and we create a scaler called Selenium grid scaler. The grid we will rely on, we will retain on Go, and it will extract the response from hub, because the hub component we have the endpoint for GraphQL. It will return the decision response, and we extract on the capability of request and the section there. So KIDA will send the metric to SPA, and the rest of work with less SPA will take care to scale up the number of predicats of deployment. So this is the flow here. This is the decision response that's create GraphQL return, and we will write code to calculate the number of ongoing section and number of depend section, and return the metric to the method get metric and activity in KIDA, and KIDA will send the metric to SPA. So here is a table that I am list down some scenario how we calculate in KIDA, and KIDA send to SPA, and the number of nodes will be scaled up. So for demo, I just captured some screenshot here. In the standby state, there is no node in the hub, and the number of pods we only see some component belong to hub running there. When the request comes, for example, the size of request is 20. Sorry, the request is 12. So accordingly, the KIDA will calculate the response from hub and scale up the number of pods here. We can see based on the capability. The capability include the browser name, the version of browser. It will scale up there. And when all the pods is running, full running and ready, the node will register to the hub, and the queue section can be taken up in particular node. And for example, we already have the number of sections running, and the new request come. Is the KIDA will we ensure that the KIDA will working well, right? While take new requests, and you can see the number of new nodes is scaled up accordingly. So recently we using the image on Linux by Esprit and deliver belong to the Docker Selenium project. You also can deploy the grid in Kubernetes with using another function from Relay node. It can connect and route the request to, for example, we have few test cloud vendor. They provide the real device, the virtual machine running on cloud. We can rely both on-prem and test cloud. So I also mentioned the table with the feature with 3 different deploy. For example, you deploy the grid with Kubernetes with the pre-solution that the Docker Selenium deliver. So if your project only worry about the browser, you only check the 3 popular browser, you can use the first solution. For example, you worry about Linux, Windows, or macOS, you can using the 2 solution with hybrid on-prem and also the test cloud solution. But the cost you need to charge, feel free for the test cloud. And the third is for advanced user. For example, some organization, they have the infrastructure. You can create the test resource pool with all the platform you need, and you using the Relay node. Instead of rely on the best service, your organization set up a resource pool yourself. So the last one is Kubernetes deployment very complex. So Docker Selenium project, we also provide the Helm chart to deploy on component with auto scaling and monitoring solution. So just a single command, Helm upgrade or something, you can deploy on the diagram. And here is some reference. The Selenium Grid Core and Docker Selenium and Selenium Grid Scaler in the KIDA project. Yeah, that's all from my side. So.
Thank you for that presentation, Viet. Very good. Still want to take some questions. Any questions from the floor? We got a microphone to pass around. I have a question, which is when you scale up those pods to align with the queue size, each pod itself running on Kubernetes is an instance, right? That'll be running for a few minutes while the Selenium scripts are executing.
No, it will running until your test finish.
Until the tests finish?
Yes.
And so if I scale up to 12 instances, I'll be incurring the cost for those kind of machines running for those tests, right? From a cost profile,
yes.
If I'm testing, each time I would have a ramp up of nodes on the Kubernetes and then a ramp down again.
Yes.
After the test is finished.
Yes, correct.
Okay. Understand. Yeah, so I have to decide. There's a question over there. So we have to kind of decide how many tests to run and how frequently to run the tests, because there's also a cost for each testing cycle. Or is it because you have to scale up the instances that are running, right?
Yes, I think it's rely on your project cycle. For example, in the regression test phase, the number of tests is need 1,000 of section, 1,000 of nodes to parallel run, and then we take just, for example, few hours for the course. We need to 100 or 1,000 nodes scale up.
Yeah.
Then in up, after that, it will scale down because we will combine both horizontal scaler and also the hardware scaling there.
Okay. That's helpful. Thank you.
Yeah.
Yep. Got a question there?
Thank you for this lection. I'd like to ask, is it possible to manage cookies and user agent for all machine from the hub? I mean, like when we work with Selenium directly, we can control this stuff. But when we work from the hub, how we distribute to machine?
I think it's depend on between the hub and WebDriver function. And I think your question is you want to sell the cookie, right? The
Cookie user agent also, because for example, if we test like a project develop, we need some cookie with credential, for example, and I need to work with credential at the same time.
You mean the hub we deploy with, for example, basic Auth credential? Yes, actually, let me go back here, let me. So here is a sample WebDriver code in Python. For example, here in the parameter command executor, if the crease you deploy with basic Auth, you can embed the username and password to the URL of the hub.
And it's go to all machine at the same time from the hub, correct? Or each port?
Actually, each
separate. Perfect.
Yeah.
Okay, thank you.
Still open to any questions on this topic of automated testing? Okay, seems like the crowd is happy. So thank you very much, and we'll wrap up there. Thank you.
Yeah, thank you, everyone.
Okay, so we're going to do the closing now, and we're going to bring everybody in. And so I guess we'll have to squeeze a bit. Yeah, good. I think Roland's saying everybody stay seated.
For the yes, can we do this?
Before or after this?
Now.
Now, okay.
Now. Wait.
Yes. What was the slideshow? Do you see better than your customer?
The three dots.
Three dots?
Yeah.
Which one is slideshow?
No, the next. No, not one. The first one.
Thank you. Okay.